Assalamualaikum and a very good evening to Dr. Khadijah and our fellow friends. We are going to present on our topic, which is the detection of SARS-CoV-2 using reverse transcription polymerase chain reaction RT-PCR. So in this presentation, we are going to talk about the principle, the advantages, the method and the limitations of RT-PCR.
The principle for detection of SARS-CoV-2. Firstly, isolate RNA and create cDNA because SARS-CoV-2 is made up of RNA. It must be isolated from the sample and convert to DNA because PCR works more efficient when DNA is used. This is accomplished by the enzyme reverse transcriptase, resulting in complementary DNA. Second, extract the cDNA encoding SARS-CoV-2 RNA from other RNA in the sample, such as bacteria or viruses. This is accomplished in PCR by detecting and amplifying viral cDNA in three steps, which is annealing, denaturing, and elongation. For denaturing, heat the mixture to 94 Celsius for 15 to 13 seconds to denature double-stranded molecules, which breaks the hydrogen bond between the double-stranded cDNA into two single strands. For annealing, primers, which are the short sections of genetic material that correspond to parts of the target organism specific to the SARS-CoV-2 cDNA, bind to each strand of specific cDNA, ensuring that only SARS-CoV-2 cDNA is amplified. And for elongation, the original cDNA strands serve as a template for enzyme polymerase. It adds complementary nucleotide to the ends of the primers, resulting in the formation of a new complementary strand. Next, detection using CT values. CT, which is cycle threshold values, count the number of cycles before the fluorescent signal exceeds the background, indicating infection with SARS-CoV-2. The lower of CT number, the fewer cycles required to pass the threshold, and the higher the viral load in the sample. Lastly, interpreting the results. RT-PCR has a high clinical specificity, so we can be confident that those who test positively are infected. The accuracy of test is determined by the variety of factors, including the quality of sampling, the stage of disease in which the patient is, and whether or not the conditions are adequately controlled.
I will continue this presentation with my part, which is the method of detecting COVID-19 virus using RT-PCR machine. The first step is the sample from certain body parts of a patient will be taken, such as from nose and throat. This is like the common nasal swab that we do to detect the COVID-19 virus at the hospital or clinics. The sample will be treated with several chemical solutions. It will remove substances such as protein and fats. This process will only extract the RNA of the virus if it present in the sample. This extracted RNA is a mix of the person's own genetic materials and the RNA of the virus. The RNA is reverse transcribed using specific enzyme, which what we call reverse transcriptase. Additional short fragments of DNA that are complementary to specific parts of the transcribed viral DNA will be added. If the virus is present in a sample, these fragments will attach themselves to the target section of the viral DNA. The mixture is then will be placed in a RT-PCR machine. This machine cycles through temperature that will cool and heat the mixture. This process will trigger a chemical reaction that will create new identical copies of the target sections of viral DNA. The cycle is repeated over and over to continue copying the target sections of viral DNA. Each cycle doubles the previous number. 2 copies become 4, and then 4 will become 8, and so on. A standard RT-PCR machine usually goes through 35 cycles. A fluorescent dye can be seen and measured by the machine's computer and presented on the screen. When a certain level of fluorescence is exceeded, this confirms that the virus is present. The number of cycles will determine the severity of the infection. The fewer the cycle, the more severe the viral infection is.
There are several advantages of using RT-PCR technique for the detection of SARS-CoV-2. First, RT-PCR only requires a smaller amount of samples for gene expression studies. Next, RT-PCR does not rely on post-PCR processing such as agarose gel electrophoresis. It is simple, easy to use, rapid, and cost-effective. The RT-PCR technique has high sensitivity and specificity, hence can deliver a reliable diagnosis in a few hours. RT-PCR technique use fewer pipetting steps. Thus, it can reduce the risk of contamination by extraneous DNA.
Lastly, I will talk about the limitations of RT-PCR. So the first one is long turnaround time. It might take around 14 days to show an accurate result. The second one is uncomfortable for some people, especially children. Deep nasal swabs might be uncomfortable for some people, especially kids, as they don't used to it and can't bear with the pains. The third one is real-time RT-PCR is very often multiplexed with co-amplification of several targets, as positive test is made when an exponential amplification curve with a cycle threshold value less than a given threshold is present. It is determined by the total number of cycles programmed for the test as well as the rate at which the test is cycled. The next point is false negative. Molecular tests have been shown to produce results that say the patient doesn't have the virus while they actually do have the virus if the sample is not properly obtained or if the person is tested too soon after viral exposure or too late in their infection, and the rates of false positive have ranged from 2% to 37%. The last limitation of RT-PCR is the decision makers in laboratories do not have enough time or data. As the test taking too much time, they invented a way to test RT-PCR, which is PCR kits, but it is not as accurate as the test that held in laboratory.
That's all from us. Thank you for your attention and have a good day.